Welcome back on the last of the video series on extra virgin olive oil authentication using portable NIR spectrometer. We will process our data using various algorithms integrated in the cloud software. To create the model, select the particular collection file performed in the previous video. From the Spectrum tab, select the attribute you are interested in to process the data. In our case, we want to process percentage extra virgin olive oil. Turn off custom mode and on for average scans. Select the pre-processing methods to use for model creation. We have 4 choices to select from the Look in Arrow window. Please refer to the method protocol for the description of each algorithm. The default view shows the spectrum. But to see clearly the differences between the samples, click on the PCA icon. Here, you can see how good the separation between the sample groups is. Then click Create Model. The model name is automatically written, or you may edit it if required. The pre-processing and cross-validation fields could also be changed. For the algorithm, we select here partial least square regression since our data is suitable for creating an estimation model. You may turn on or off the outlier detection. The number of latent variables could also be entered here. The default range is 1 to 5. If we opt not to enter any values, the software will generate appropriate number of latent variables. So we press Run to initiate the model creation. Checking on the initiated model, go to Model tab and wait till the In Progress status is gone. Click anywhere on the particular model to display the known versus estimated plot. The x-axis shows the known values, and the y-axis the estimated values. You can access additional statistical information below the graph. The created model shows good R-square and RMSE values. However, we still need to test the goodness of fit and the predictability of this model using a test dataset which wasn't used for the generation of the model. So now we prepare for the analysis of the test sample set as shown in the previous video. To make it easier, we just copy the collection file for the calibration set so it contains the same attributes. Start to measure the samples that need to be tested by the model. Once the analysis is done, go to Model tab and click the sample collection which was used for the generation of the model. Then click on Test Model. A new window will open. Select the test dataset from the drop-down menu. Then select the target attribute, which is the percentage purity of olive oil. Click on Test and OK. Open the downloaded CSV file, which you can find either on the top right side of your window or on the bottom left. Here you have all the information such as the model name, the collection used for creating the model, the target attribute, the pre-processing used, algorithm used, etc. The important Parameters or criteria here are the number of correct predictions, root mean square error, correlation coefficient, the bias, and also the standard error of prediction. Below you can find more information on the model performance against the samples from the test collection set. Here is a comparison of the performance of 4 different models on our test samples. The log-R and normalized preprocessing model shows the highest prediction rate, however it has also the highest RMSE, bias, and SEP. The process and normalized could be the best model to be used for predicting our test samples as it is significantly lower in RMSE, bias, and standard error prediction in comparison to the aforementioned model. This concludes our exercise on the analysis of adulterated extra virgin olive oil using a handheld NIR spectrometer SCiO. Thank you for your attention, and we hope you find this video series useful.